For stoichiometry, we're going to first start off with a mole-to-mole stoichiometry problem. When we're doing a mole-to-mole stoichiometry problem, it's just a one-step conversion. In the questions, like the ones that I have listed below, you're going to be given moles of something. So in this case, we're given moles of lead. And we want to know how many moles of hydrochloric acid we're going to have when we go through that reaction. So every time we do a stoich problem, we're going to need to know our balanced chemical equation. Reaction, not equation. When we have our balanced chemical reaction, what we're going to do is we're going to pull out something called a mole ratio. Your mole ratio is going to help you to bridge the gap to get from your given to your unknown. Where the mole ratio comes from is the coefficients in your balanced reaction. So I'm going to do a couple of these problems from our homework packet just so you have an idea of what's going on for your mole-to-mole stoich problems. Your first step anytime you have a chemical reaction is we need to balance it. So on this problem it says how many moles of nitric acid will be produced if 0.51 moles of the N2O5, which is dinitrogen pentaoxide, reacts according to the following equation. So right now I have an unbalanced equation. I need to balance it out. So I have two nitrogens, two hydrogens, two hydrogens. On this side we have 6 oxygen and 6 oxygen. So it's a 1, 1, 2 to balance out my reaction. We don't normally write the number 1. It's like a ghost. So our job in this problem is to start with 0.51 moles of the N2O5, and we're actually going to write that out in the formula. Now when we do this problem, we need to take our moles of the dinitrogen pentaoxide and we need to cancel it out and go to the unit that we're looking for. So how I go from moles of one thing to moles of another thing is that mole ratio. The mole ratio comes from these coefficients. So if we have moles of the dinitrogen pentaoxide on the bottom, or on the top, we're going to put it on the bottom. On the top of that, we're going to put what we want to go to, which the question says, how many moles of the HNO3? So what this is going to do for us is it's going to help to cancel out moles of the N2O5. That's going to give us moles of HNO3. So the numbers that are associated with the moles comes from the balanced equation. There's a 1 right there. So we have 1 mole of the N2O5. We have 2 moles of the HNO3. So now we are left with moles of HNO3, which is what the question asks for. So now to do my math problem, we multiply across the top. So I take 0.51 times 2, get an answer. We're going to divide by 1, which is the same number, so we don't actually have to do anything else with it. At the beginning of my number, I started with 2 sig figs, so I need 2 sig figs in my answer. So we get 1.0 moles of the nitric acid. Now to do another problem, we have carbon will react with zinc 2 oxide to produce zinc and carbon dioxide. I don't have a reaction, so I'm going to have to write it out. So we have carbon reacting with zinc 2 oxide to produce zinc and carbon dioxide. Now my first step before I do anything is I need to balance my reaction. I have 2 oxygens, 2 zinc, 2 zinc. Now everything's balanced. So now to do this problem, we start with the number that's given in our question, which is 0.38 moles of your zinc 2 oxide. We want to know how many moles of carbon dioxide are produced. So this guy down here. So moles of the ZNO go in the bottom because top and bottom cancel. Moles of what we want to go to goes on top, so right there. For the numbers, we're going to pull out the coefficients from my balanced equation. There's a 2 in front of my ZNO. There's a 1 in front of my CO2. So on this one, I take 0.38 times 1, which is just 0.38. divided by 2. And I get 0.19 moles of CO2. So hopefully you understand that in a mole-to-mole problem, these are actually the most simple type of stoichiometry problem, we have to get a mole ratio. Mole ratios come from the balanced chemical reaction. That's how we cancel out moles of the unit that's given, and that'll take us to the moles of our unknown.